Hi everyone. So welcome once again. We are talking about demand forecasting, and in this connection, friends, we have already discussed in the last video the least square method and the trend projection through visual approach. In this video, we will talk about the moving averages, and in the moving averages, what we have to understand is that we are trying to forecast the future sales or future demand, and for this we have one very easy tricks, that is I can take the average of the previous period and forecast the future. So for example, if I have 3 months data, I can take the average of the 3 months and consider this to be the likely sales of the coming month. So I think it is logical and it is quite acceptable that I take the average, right? But friends, when I take the average, there is one difficulty. The difficulty is that when I'm taking average of a long time series, suppose I have for 24 months data. So all the 24 months data I club together and take the average, it's considered to be unscientific and unbiased because we have a mixture of old and new and medium data. So as a result, we have to take into account some other average, and that average is called moving average. Okay, so what is moving average? We are taking averages, but these averages will move on and on as time rolls, right? So let's see how we can do the moving average. So for example, I have this actual sales data, and these are the quarterly values. Okay, so quarterly sales data is available in front of us, and we are to do the forecasting for the 13th period, say. So if I have to forecast, then I have to do it on the basis of averages, and I will take the first average, that is the simple moving average. Okay, so I'm writing here SMA, simple moving average. Okay, so we are talking about moving average. And here, friends, we are talking about the simple moving average. Simple moving average, let's consider to be take up a time period. Say for example, we take 3 quarterly moving average because we have quarterly data. So we will take the 3 quarter averages, then the next 3 quarters averages, then the next 3 quarters averages. So the past gets mixed with the second quarter, and this way the averages will roll on. Let's understand how we will do. So what we will do is that we will first find out the average of these 3 months. 3 quarters, these 3 quarters, and we will write the value in the center. What is the center here? The second one is the center here. Then we will take the next 3 months, that is these 3 months, and we will write the value in the center. Okay, then we will take the next 3 months, we will write it in the center, and then we will go on this way, and that will be your 3 months moving average or 3 quarterly moving average. So let's do it and write it here. So friends, I have taken the moving averages. As you can see, the first 3 periods, the whatever is the average, this plus this divided by 3, it will come in the middle. This plus this divided by 3 will come in the middle. This plus this divided by 3 will come in the middle. So this way I have taken the 3 quarterly moving averages. Okay, and this is the simple moving average. Let's go to the next type of moving average, that is the weighted moving average, WMA. What is WMA? WMA stands for weighted moving average. So the idea here is that when you are taking the average of the 3 months, you are considering all the 3 months equally important. If the 3 months are equally important, then again there is a kind of bias, because we generally give less weightage to the months which are older and give more weightages to the months which are very recent. Okay, because our future is going to be linked with the recent things that is happening rather than the old. Of course, old will have a kind of reflection, but it will have lesser as compared to the recent. So that's why we will give less weightage to the old data and more weightage to the new data. So in this case, what we will do is that we will assign weightages 1, 2, 3. 1 will be given to the first, 2 will be given to the second, 3 will be given to the third. Again, this will be 1, this will be 2, this will be 3. Again, this will be 1, this will be 2, this will be 3. So how we will compute? Let's see. So friends, the weighted moving average calculation will be, I'm showing you the first to one, then the rest will be easy. 1, 2, 3. So I will write 1 into 842 plus 2 into 939 plus 3 into 1236, and the entire thing will be divided by 6. That you will write for the second month. As we have written here, the same thing you will write, do this calculation and write here. Similarly, the next period, you will start with 939. So 939 will be given a weightage of 1 this time, plus, see, it was given 2 weightage in the previous time, but now it will be 1, because it is becoming older now. 1236 will be multiplied with 2, plus this will be multiplied with 3, and this way we will go on for all the time values, and we will write it against their middle months. Okay, so 1, 2, 3, the middle month is the second month. Let's do it. So friends, let's understand the weighted moving average. Weighted average, as I have already told you, that we are going to do what? We are going to give weightage. So 842 will be given a weightage of 1, 939 will be given a weightage of 2, and 1236 will be given a weightage of 3. So how we will do? 842 into 1 plus 939 into 2 plus 1236 into 3 divided by 6. Why 6? Because 1 plus 2 plus 3 is equals to 6. So I am writing this value. Similarly, you will do 939, 1, 2, 3, 6, 875, multiply with 1, 2, 3 and divide by 6. You will get this value. So this is the weighted moving average. So here the objective is that I will give more weightage to the new values and give less weightage to the older values. And you see, the averages are getting rolled over the years. So we are having touch of the past, but we are not including past so much as we are taking recent, giving more weightage to the recent. Now friends, what we have done here, you can see we have written the values in the middle. We have written the values in the middle. Okay. But friends, if you have even number, then how will you write the values? Because you have odd number 1, 2, 3, so middle is there for you. 1, 2, 3, middle is there. But suppose it is 4 quarterly moving average. If it is a 4 quarterly moving average, then you have 1, 2, 3, 4, and there are 2 months in between. So you have to write in between the 2 months. So in between the 2 months comes here. Okay, so you can understand the in between the 2 months will come here. Similarly, 1, 2, 3, 4, these two are the middle months. So in between the 2 months comes here. Then you will go on 1, 2, 3, 4. In between the 2 months will come here. Then 1, 2, 3, 4. This way you will go on and write the values in the middle. Okay friends, so this is how we do the 3 quarterly moving average or 3 months moving average, the same procedure, or the 4 quarterly moving average or the 4 months moving average. Okay friends, now the question is, if your 4 quarterly moving averages are coming in middle, okay, it is coming in middle, and we need to place it at the center. Okay, see, this is already centered. The 3 quarterly moving averages are already taken, the averages are taken, and it is been centered. But your 4 quarterly moving averages are not properly centered, because you are just writing it in the middle between 2 and 3. Okay, between 3 and 4. So this way you are writing. Now you need to center it. Okay, so we call it centered moving average. In order to get the centered moving average, you have to write it CMA, centered moving average. So you have to take the average of these two and write in the middle. Okay, so if you write the average of these two and write in the middle, so you will get the values here. Okay, so let's take the averages and write the values in the last column. So friends, what we have done is the quarterly moving average, which is now centered. So see what we have done, we have centered it now, not centered, sorry, we have written it in the middle. Now we need to exactly center it. So I will just take the average of these two and write in the middle. So we get the values in a row now. Okay, then I will take the average of these two, right in the middle. We get all the values, average of these two, right in the middle. So this is the centered moving average. Now, will the centered moving average help us in forecasting? It will not directly tell us what is the forecasted value. The averages are just centered. Okay, this will help us in some technique. Now what is this technique we are going to learn now? Friends, we have seen so far that we have to predict or forecast the future. We have done the trend projections, we have done the least squares, and here we have done the moving averages. Moving averages, the logic is clear to us that we want to take average, but the average should be moving or rolling with time. Okay, so we have done the simple moving average, we have done the 3 quarterly moving average or 3 months moving average, the same procedure, and we have done the 4 quarterly moving average. Why we have done 4? Because here it is a even number and that is a odd number. The 4 quarterly moving average needs to be centered because they are not centered properly. How we have done, I have shown you. Now friends, we are trying to get the prediction, or we are going to know how will be our forecast based on the trend. Okay, based on the trend. But since we have a long data set, and this long time series data will have a lot of disturbances in between. There could be some fluctuations in between. For example, there can be seasonality. In some seasons, there can be some ups and downs. For example, cold drinks. The sales of cold drinks will be peaked at some point, will be very low at some points in some seasons. So your trend is having some fluctuations which you want to remove, because if you want to know a long period, long pattern or long trend, you need to remove all these fluctuations. And this seasonality that I said is a seasonal factor because of seasons. This is called seasonality. You have to remove the seasonality from your time series in order to get the perfect trend which you use to forecast, right? So we need to de-season it. Generally, when you have a time series, the time series has got certain components. The first is the trend component, and then we have the seasonality component. Because of seasonality is included in the trend, and we have the cyclicality. In an economy, there is a cycle, like the boom, then the recession, then the depression, then the recovery. So there can be different degrees of sales or different volume of sales or demand respective to the period, and therefore there is a cyclical movements that is going on, which is also present in the time series data. And lastly, there can be an irregular trend, something which happens because of which is more or less erratic in nature, something which is not explained properly, very mixed kind of trend. So these things are there in a time series data. So you want to know the pure trend so that you can forecast the future. So you have to decompose your time series into these components. This can be a multiplicative model or it can be an additive model. Okay, and you want to remove mainly the seasonality. See here, the cyclicality, it cannot be removed because it's a long process. The cycle is sometimes not complete. So cyclicality cannot be removed, but it is there with the, suppose with the I. So cyclicality and irregular, we are keeping it inside the I. So we want to first remove the seasonality. The seasonal factors that we remove will smoothen our data. So remember, the idea of the entire moving average is to smoothen our data so that there is not fluctuations. So if you have a data like this, you want to get a smooth data, okay, a smooth data. This is a very volatile or a fluctuating data. With moving averages, we are able to smoothen the data, and through this we are going to do, through the smoothing, we are trying to remove the seasonality. We call it de-seasoning. So with this data, let us see how can we remove the seasonal component from the time series. This is our centered moving average, and let's start from this point how to do the de-seasoning. Okay. So friends, let's do the de-seasoning with the help of the same data set. So we have done the centered moving average, we have done it. Now what we will do, we will divide the actual sales with the centered moving average first. This is our first thing. This is called ratio. We are calculating the ratio of the actual to the centered moving average, and we find these are the values. Okay, so the first value is given here divided by the centered moving average, we get this ratio. Okay, now the question is, what we are going to do is to find out the seasonal index. For finding the seasonal index, we are going to do what, we are going to make a table here. For this table, we are having 4 quarter data. You can see 1, 2, 3, 4. That means 1 year is over. 1, 2, 3, 4. Second year is over. 1, 2, 3, 4. That means third year is also over. So I'm writing here year 1, year 2, year 3. Okay, and each year has got 4 quarters. Now we will see that the first year, when you are doing the ratio, there is no value in the first quarter, no value in the second quarter. So there is no value in the first, no value in the second. But we have in the third and the fourth quarter. So I'll write the value in the third quarter and fourth quarter. In the second year, we have all the values 1, 2, 3, 4. So I'm writing 1, 2, 3, 4, all the values. These are the ratios. Then the next quarter 1, 2, 3, 4. I'm writing 1, 2. See, we don't have the last 2 period. For the third year, we don't have the last 2 periods because when we have done the averages, we did not get for the third quarter and for the fourth quarter. As you can see here, this is gone, second and third and fourth is there, then first, second, third, fourth is there, then we just have first and second because we are based on the centered moving average. So we have just the first and second. Okay, now what we will do is that we will try to average these two. Average these two. So I'm writing here average of quarter 1 of all the 3 years, quarter 2 of the second, all the 3 years, quarter 3 of all the 3 years, and quarter 4 of all the 3 years. I'm writing here, and here. Now I will total all the averages. It comes to 0.9995. Now, this total per quarter should be equal to 100% or 1. Okay, so the total should be 1. That means for the 4 quarters, it should be 4. So, if the total is not coming to 4, then we have to adjust these values so that it becomes 4. How we will do the adjustments? I repeat again, the total is coming to 0.9995, but it should come to 4. So in order to come to 4, I have to change this value so that the total becomes 4. In order to change this value, I will do some adjusted averages. How I will do this? The formula is very simple. You have to write 0.219 divided by 0.9995 into 4. It's simple. So you can see 0.219 divided by out of how much? 0.9995 into 4. We want 4. So that means proportionally I am adjusting these values. I am raising these values proportionally. This divided by this into 4. 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 I am writing the values. This and this. Since space is limited, so I cannot show the calculation for each of this. Now these values I will write as seasonal index. So we can call it seasonality index or seasonal index. 1, 2, 3, 4. Okay, so 1, 2, 3, 4. Again you repeat 1, 2, 3, 4 and then 1, 2, 3, 4. So you get seasonal index for all the quarters. Okay, now you will get the de-seasoned data. How you will get the de-seasoned data? You have to divide the actual data with the seasonality index and you will get the de-seasoned data. Right? So if they ask you that find out the de-seasoned value or find out the seasonality factor, then you have to exactly follow this method. Okay. Now the question is, as I told you, we are going to decompose the trend into the time series into trend, seasonal, and we have the irregular comprising of cycling and other things. Now we got the seasonal factor, seasonal values. Now we can find out the trend values. How can we find out the trend values? Though I am not finding it here, I'll just tell you how to find the trend values. Remember, we have done the least square method. In the least square method, y is equals to a plus bx. So you find the value of a and find the value of b. You consider this to be, these values, actual sales value to be y, and then you find the value of x. Take any quarter as 0 and go back and do -1, -2, -3 and come forward and do 1, 2, 3, 4. And then you follow the formulas to find out a, find out the value of b. Once you have this, then you substitute the value of x as 1 for the first quarter, 2 for the second quarter. You will find the trend values of y. So you will find the trend values here. So once you have the trend value, you have the de-seasoned value. I mean, you have the trend values here. Okay, so I am coming to the other part now. Just remember that after you have de-seasoned the data, next job is to find out the trend values. How to find the trend values? Use the least square method. Using the formula, you can find out the trend values. And then dividing the values of this de-season data by the trend values. When you have this de-season data, means this data has the trend values. So you want to take out the trend values. So you have taken out the trend. I mean, when you divide this with the trend values, you will get the trend value out of it. Okay. So I repeat again, now by dividing this by this, you get the cyclical and erratic trend. So friends, no need to go that much. You just have to find out what is the de-season data. This is the de-season data. From there you can also you can find out the trend values by using this formula. And then the last job is to find out the cyclical and irregular component, which you can do by dividing the de-seasonal data with the trend values. De-seasons data with the trend values, you can find out the cyclical and the irregular components. So friends, that's all for today. I think we have talked about the moving averages, how to calculate the moving averages. How can you use the centered moving average to de-season the data? You have done the de-seasoning with the help of these ratios. This ratio, you have calculated the seasonal index, and with this index you have got this de-seasoned value. You can find out the trend value as you do with the help of this equation, least square equation, and with this you can just divide this with this de-season data with the trend data. If you divide, you are taking out the trend, and ultimately what is left is the cyclical and the irregular component. So thanks for watching this video. We will come and meet again in the next video with a new topic. Till then, goodbye.